So now we're going to go through an example on how to reflect coordinate points over the y equals x line. So remember, the rule is the most important thing. So here's our rule, and what the rule says is that we have to basically flip the x and y coordinates. So let's go ahead and do an example. So when it comes to transformations, the most important thing is knowing the rule. So I'm going to go ahead and write the rule as over here. I'll put x comma y is going to become y comma x, and this is basically the rule. So it says quadrilateral JKLM has vertices, and it tells us where they're located, and they want us to graph it and its image over the line y equals x. Now remember, the line y equals x, remember that it's in the form y equals mx plus b, and it just basically the slope is 1, so that's why it just becomes y equals x, because the slope is 1. And the y-intercept happens to be at 0, so b would be 0, and so that's why that's that y equals x line. So let's go ahead and apply the rule for each of these points. So our first point is J, which is at 2, 2. To show the transformation, we get to J prime, and in this case it looks like nothing happened because both of the x and y values were 2. So it looks the same. Let's do K. Let's see what happens with K. 4, 1. So this one is going to become K prime. And for sure here we can flip them. So your y value will become your x value, and your x value will become your new y value. And let's keep going. After we have been able to apply the rule, we can go ahead and graph this using Desmos. So here we have the pre-image, the quadrilateral JKLM. So now I'm going to go ahead and plot the points for my image after its transformation. So my orange figure now is the quadrilateral after its transformation. And let's go ahead and draw the y equals x line. There it is. And so that y equals x line is your line of reflection, so your mirror, if you will. And so you can easily see how the gray figure was transformed into this orange figure. It was flipped over the red line, y equals x line. All right, I hope that helps.